Imagine a future where your entire mind, your memories and your personality, could be copied directly into a machine, allowing you to live forever in a digital space. To get there, we have to clear an immense scientific hurdle. First, we need to figure out how to perfectly recreate the human brain, the most densely complex structure in the known universe. There is a massive gap between a server farm churning through raw data and a biological mind that actively experiences reality. We know exactly how to build incredibly smart machines. What we don't know is whether a rigid architecture built from silicon and binary code can ever host a fluid, self-aware mind, or if we are simply chasing an impossible ghost. Inside your skull is a chaotic, dense forest of nearly 86 billion neurons. They operate in a massive parallel symphony. A single thought triggers a tangled web of trillions of interconnected synapses. This biological network is fluid, relying on a shifting, messy mixture of chemical and electrical pulses to process the world. Computer hardware processes reality in the exact opposite way. It is entirely rigid and mechanical. The engine driving this digital world is the central processing unit, or CPU. Instead of a massive parallel symphony, computer architecture pushes information sequentially. It forces data through strict logic gates, relying entirely on absolute ones and zeros to calculate an outcome, because brains and CPUs process reality in strictly opposing ways. Modern computing is not a faster version of biology. It is an entirely alien operating system. Computer scientists are now trying to bridge that structural gap by forcing rigid hardware to act like biological wetware. They use artificial neural networks to simulate the learning structures of a real brain inside a digital space. This is exactly how large language models operate. By absorbing enormous data sets, they use heavy pattern recognition to convincingly imitate human thought and conversation. But there is a strict boundary to this capability. An AI lacks actual comprehension. It is merely predicting the next logical sequence of data mathematically based on the patterns it has already seen. AI represents a staggering achievement in pattern recognition, yet it only perfectly imitates specific parts of the brain. It does not possess a true intellect or an internal life. There is a global scientific race to move beyond software imitation and physically reconstruct a brain, point by point, inside a machine. Just mapping a fraction of our biological pathways requires vast physical infrastructure and extreme computing power. Vanguard efforts like the European Human Brain Project have spent over a decade working toward this exact digital mapping ambition. Researchers have invested billions of dollars and are getting remarkably close to building a complete structural map of our neural pathways. Having a perfect map is a massive scientific leap. However, mapping the physical streets of a city does not automatically generate the life that walks through it. This brings us to a critical limitation. At the edge of modern science, perfectly simulating the physical architecture of a brain does not guarantee a mind actually turns on. Philosophers and scientists call this the hard problem of consciousness. We currently have no scientific way to measure, locate, or write code for subjective emotion, free will, or self-awareness. Think of it like a weather simulation. You can code a perfect mathematical model of a hurricane, but the monitor itself won't get wet. The same logic applies here. Perfectly simulating biological neurons offers zero guarantee of creating actual felt consciousness. Optimists argue that if you push a simulation to a high enough level of complexity, consciousness might eventually emerge organically on its own until science can definitively prove what sparks conscious thought. Any digital brain will remain trapped at the mechanical level, a flawless machine running in the dark. Fast forward to a hypothetical future where the ultimate promise is achieved. Your brain is completely uploaded, and a perfect replica opens its digital eyes. This machine remembers everything you remember. It laughs at the same jokes, and it behaves exactly as you would. But a skeptic would warn you that this flawless replica might just be a philosophical zombie, a hollow shell executing incredibly complex code, with absolutely no one home inside. If this perfect digital replica is turned on, is it actually you experiencing that reality, or just an imposter wearing your data? What do you think? Could a machine ever become truly conscious? Tell us in the comments.